Welcome to the Home Renovation Show, a show where we tour the coolest home renovations in LA to learn about construction and how you can add value to your real estate. Today we're in Silver Lake, and just minutes from the reservoir is this beautiful 2,300 square foot Craftsman. And the homeowner here ran into some major problems with their foundation. And instead of repairing it, they decided to build out a full basement underneath the house. So today we're with Alpha Structural, and they're gonna walk us through the steps of the construction, tell us what it cost, and at the end, we'll decide if the project was worth that cost. So without further ado, let's get into it. All right, Kyle. So before we get into all the steps of the construction and everything, first tell me, how did this project even begin? What was the goal? What was the vision? How does somebody decide to do a full basement in Silver Lake? What was the thought process here?
Well, as with a lot of projects that we work on like this, it usually starts with a call about distress, foundation distress, right?
Okay.
We got this call because this is one of the oldest craftsmen in the Silver Lake area. And it's a turn of the century craftsman, has a brick foundation.
Oh, wow.
Brick foundation, big craftsman in a hillside area. This thing was 6-8 inches out of level, really distressed foundation. So that was the initial objective of this client, was the floors were severely out of level.
Oh, wow.
There were cracks everywhere. The door frames were very out of square. And the whole place was crooked. So we really evaluated it, and because this property is in a hillside area, it requires geotechnical reports. We got those reports done, and we found that this lot is on a pretty thick wedge of fill. And
is that good?
No, it's very bad. Yeah, fill is soil imported and brought in to create a sort of level pad in a hill. Yeah, that's right, artificial fill, and it's uncertified artificial fill, right? So
what's certified, uncertified fill?
So typically pre-1963, that fill that was placed in hillside lots is uncertified.
Oh.
You see a lot of certified fill after 1963, but that doesn't necessarily mean it's good material or good fill.
Okay.
And then of course the later the building is developed, the better the fill and grading gets, right?
So what does certified mean?
Certified is where geologists actually come in, they inspect the lifts that are placed.
Oh, wow.
And they inspect the process of the grading, so they can attest that the material placed is actually decent material.
So before 1963, people were just pouring dirt and building.
Yeah, just importing massive amounts of dirt. And with a lot like this is turn of the century. This is low 1900s, right?
Wow, yeah.
So this had zero input of any geologists whatsoever.
Yeah,
right?
just random dudes.
Just people building it. Now they framed these houses very well, but foundation technology was really non-existent at the time for residential buildings. So this had a brick foundation, which was standard for turn of the century, but brick foundation in hillside area on uncertified fill. Pretty bad combination.
Yeah.
Right? So this project, just to fix this house, required caissons. Lots of caissons.
And caissons are what?
Caissons are deep foundations that penetrate through different layers or strata of poor geology and fix into competent material or competent geology like bedrock or firm native soil.
So I know the standard is for the footings, you got to go down 2 feet.
Yeah, so in flat areas, code minimum. In areas with clay, which is very prevalent here in LA County, it's 2 feet minimum for perimeter foundations.
Okay.
This would have been 18 feet deep.
Oh, wow.
Yeah, these caissons would have been at least 18 feet deep, tight access. Not a very good situation here in terms of repair, because it's a pretty costly repair.
Yeah.
So that's where the idea and the concept of this project was born, where if we have to put these deep caissons in 18 feet, 25 feet, it was a mix of 18 to 20 plus feet. Why don't we add value to this?
So what was he looking at for repair cost? What was the repair looking like?
6-figure repair.
Oh, wow.
Yeah, 6-figure repair for those caissons. And a very similar permitting and approval timeline, because it has to go through grading and building and safety, different divisions that regulate hillside construction. So similar time frame, 6 figures, straight house.
Yeah.
Or let's talk about big square footage underneath it.
Yeah.
And so that's where the project concept was born.
Okay.
Yeah.
So he was thinking, all right, I already got to pay 6 figures to fix this thing. Why not just juice it up and add an extra 1,200 square feet or whatever this is.
That's right.
And add possibly 6, 7 plus figures of value, right?
That's right. Yep. That's exactly
Nice.
what happened.
Okay. So then he hires you guys. So I guess that's the vision for the project,
Yeah.
right? Then he hires you guys. What's the first order of business? What do you guys have to do?
So first order of business is we establish, and this project obviously, and it happens, this project had different phases and different concepts, right? Initially, it was a smaller addition, and then it grew and grew and grew
Always
and grew.
does.
It always does, right? So initial phases, we obviously are usually one of the first calls, right? We get a call because the house is distressed. And we present different ideas of repair and potential value add options, right? So we'll usually prepare a preliminary design concept and what's called a rough order of magnitude estimate. It's a ballpark figure, right, based on preliminary design work that we do, knowing a lot about the area. We don't have soils reports on projects. We do. Now that rough order of magnitude estimate gets firmed up a little bit better.
So you guys can use past soils reports from like nearby properties to get a better estimate?
Yeah. We also have a vast archive of projects because we fixed thousands and thousands of buildings here in LA.
Wow.
So we can just run a search in our system for the street that we're on and pull up, 10 soils reports from projects that we've done over the last 30 years on this street. And usually there's at least, 5. Right.
So can you take like a soils report from the house next door, houses 5 doors down, and be like, okay, so this is going to be pretty much the same soil?
You can. It depends on the area that you're in, and we make a good judgment of that because there are scenarios where geology can drastically change just within 2 parcels.
Oh, really?
Right? Yeah. Oh, yeah. We worked on houses where we put a house on caissons that had 3 feet of fill, and it was sinking a little bit, and it needed relatively shallow caissons. And then 2 houses down, it was a canyon that dropped off 60 feet.
And it was filled.
And it was filled.
So then it's like...
Now it's 80 foot deep. So you go 15 foot deep
Wow.
caissons, 2 houses down, 80 foot deep caissons. Massive difference in price.
That's unlucky if you're the guy 2 houses
Very
down.
unlucky. Yeah,
Wow.
that's basically what it is. So
Okay, cool. So then you got an idea of what's going on here. You
That's
get an
right.
estimate together.
yeah. And then what we do as part of our services is we are the structural engineer, we're the permit expediters, and we're the specialty contractors. So we perform, full turnkey service for all of the structural and grading work, right? But that includes sending requests for proposals and bringing on architects, bringing on the soils engineer, bringing on the licensed land surveyor. That's required on this type of project. You need a licensed architect, you need a licensed land surveyor, you need a licensed geologist and geotechnical engineer, and of course you need a licensed structural engineer, right? Alpha Structural. So part of getting this project permitted quickly is making sure that the team is cohesive and you're getting all the right players involved for the client. Otherwise, the client is chasing around all these professionals and they're blowing them off and they have other projects and things like that. We have a huge network of professionals that we work with all the time. They get lots of clients from us. We get clients from them. It's reciprocal because it's a small community in this kind of specialized work. And so they know, hey, when we want a proposal, they send it fast because they know that this project is going to actually turn into a viable project, right? Not just some pipe dream that never happens.
Right. So this is obviously a massive project, and we'll get into the cost later. But before you even break ground, before a shovel gets here, what are you looking at as far as costs for those 5 professionals that you need just for the structural elements, right?
Yeah. So just
permitting fees, getting the plans.
Permitting. So basically when you engage in a project on this, you have to bring those professionals in, right? Generally just architectural engineering, soils engineering and surveying. It's at like on this is an addition project. So it's not the same as, replacing a retaining wall or underpinning a house on caissons, deep foundations.
This is building a full basement.
This has a very, very extensive set of architectural plans. So that's a big portion of this cost that I'm going to tell you is architectural because it's very tedious work to get a really, really nice, clean set of architectural plans down. So that cost, it's 6 figures. It's generally about, I would say 100, maybe 150 all in. Engineering, architectural, soils engineering, survey, maybe 100, something like that.
And is that a full plan?
Yeah, that's
A through Z?
That's A through Z, all the way through.
From breaking ground to you're living in this thing.
And you're getting through plan check, right? Okay. Breaking ground, you'll have some more fees. The geologist has a lot of consulting work and inspection work to do here. But a big chunk of it is the initial design and approval process.
Okay.
Right? Then you have to.
How long does that take?
So when you go through and you get all these professionals together, everyone agrees on a design, right? 'Cause that's always challenging. Is like what can feasibly be done on a tight access property like this. Does it, you spend some design time on that, you interface with the architect, then you have to cost it, and that has to go to the client. They have to really, it's a lot of back and forth to really make sure that the design parameters meet the project budget, right? So once you get through that, plan checking, designing, engineering, plan checking this, getting approvals from the city of LA in a hillside area usually takes about 1 to 2 years, depending on the area that you're in, because different hillside areas have different clearances that you have to get from different agencies, right? So if you have a power pole, add 4 months for a DWP clearance.
Oh my gosh.
If you're in Mulholland, if you're in the Mulholland Scenic Corridor, right? If you're in the inner corridor or the outer corridor, you can add up to a year, sometimes a year and a half for that.
Wow.
Or Bel Air Crest. So they have all these different zoning pockets, right? Or if you're in a historic area, Historic Preservation Overlay Zone, otherwise known as HPOZ. You have all these different pockets, right?
Wow.
Yeah, so it could get pretty
timely.
pretty time consuming in plan check, right?
Do you see that process is getting any faster with AI and tech improving?
No, not really.
No,
Yeah,
not yet?
AI hasn't really hit the cities yet. It's probably going to be, one of the last places where the cities implement it. But I have seen, especially in the city of LA, the plan checkers are more responsive, which is good. That you could see they want to get projects kind of pushed through, which is really nice. Can't say the same about other cities.
Which one's the worst? Which city is the worst with getting plans approved?
Glendale, by far, worst city ever. I'm literally borderline thinking of calling the mayor or the city council, for sure the building officials. The worst city. I deal with every city personally, from Santa Barbara County down to the bottom of Orange County. Glendale is easily the worst city.
Really?
Yeah, and I can't believe how bad it is.
And it's just because they take long to approve things?
They have the most ridiculous plan checking timeframes for different projects. And what's crazy is that they're very transparent about it too. They publicly list it on their website.
They say it's going to take a long time?
Yeah, it's like this project, 310 days. This project, 87 days. And you can't believe what you're reading.
Wow.
Yeah, it's remarkable. And what's sad is that
if 310 days is long, what's like a normal time frame?
Well, for example, this project, including engineering, right, can take a year and a half, right? But that's including full design, all of the back and forth, and architectural and engineering and soils engineering and the costing and budget reconciliation with the client, the architect. I mean,
so
all of that work, year and a half, 2 years, right?
How long would that have taken in Glendale?
Probably double.
Damn.
Yeah.
Wow.
Yeah, it's crazy. It's absolutely crazy, So people complain about Beverly Hills, people complain about West Hollywood, Santa Monica. I love those cities compared to Glendale. If somebody says, hey, we've got this big project in West Hollywood, it's like, okay, yeah, what's the problem?
What do you think is taking them so long?
I have no idea. That's why I was literally thinking about calling and setting up a meeting with somebody to give them feedback as a high volume stakeholder. We're a very high volume stakeholder of plan submittals across the entire region, Orange County, LA County, Ventura, and Santa Barbara County. So it's not like we're a shop that sends, 2 sets of plans a year. We're running probably, through Glendale, probably at least 3 to 6 projects a month through Glendale.
Wow.
Yeah, it's crazy.
So then
LA's not too bad.
Okay, so then year and a half, you get A through Z plans.
Yeah.
That's the first major thing that takes place.
Yeah.
And so you guys are involved from the beginning of that, right?
Yeah.
Putting it all together.
Yeah, year and a half, 2. I can't remember exactly how long this took because there were a lot of changes on this.
Sure.
But, if a project doesn't have major scope changes, like this expanded, I think 3 times, right? So it's like redesign. These can easily get done and approved in a year and a half.
Okay. So you've got your plans, right? Now, what's the scope of the job look like? What do you tell the client? You tell them before, don't worry about the cost. We'll talk about that later. But you tell them, okay, we've got your plans. This is going to take how long? How long is this project specifically going to take your involvement at least? Getting the structural elements, digging everything out, shoring the house up, making sure nothing's going to fall down.
Yeah.
How long is that going to take?
So the time frame takes about 6 months
Okay.
to execute the structural and grading portion of this. The phases are shoring, lifting the house, excavating and exporting all the soil, right?
So that's 6 months just for
structural.
Just for your involvement.
Yeah.
Okay,
just
cool.
So
what we're about to
hole.
talk about is going to take 6 months, basically.
That's right. Mm-hmm.
Cool.
Yeah.
Okay, so that's the scope of the project.
Yeah.
6 months. We got our vision.
Yeah.
We got a massive repair to do. Let's just build out a basement.
Yeah.
Let's offset our cost and build some equity.
Yeah.
Plans and permits, 1.5 to 2 years.
Mm-hmm.
All right, we're ready to break ground. Your involvement is going to take 6 months.
Yep.
That's the project.
Yep. 6 months. That's shoring, excavation, all the foundations, all the reinforcing steel, all the structural concrete, all the waterproofing, all the structural framing, lifting the building, and the seismic work underneath it, because it obviously has to be up to code for seismic codes, right?
Sweet.
And then once that's done, we're done. Then the general contractor makes it pretty.
Okay.
Yeah. So this was our road in with all of our heavy equipment.
Okay.
Right. And
so
then
we can pause here for now.
Yeah.
So, okay, so you guys have, wow, there's a lot going on here.
Yeah, there's still a ton of work that we have left to do. So here, this is a storage area that the client wants, right? And we're obviously reframing all of the columns, the old Craftsman columns that were here, your kind of classic Craftsman columns.
Well, what's the first step? What's the very first thing you guys do when you get here?
Demolition, site preparation, scrubbing all the plants in the requisite paths of travel.
Okay, so clearing your workspace.
Clearing the workspace.
You guys have kept a lot of plants though. I mean, you got a lemon tree over there, like right in the middle of what you're doing.
We try to keep as many plants as possible.
Okay, so clear the workspace.
Clear the workspace, then you get right into creating the access to the workspace.
So this bridge.
Well, this bridge was built afterwards. This used to be a road. That's what you have here, right?
Oh.
So this used to be a road all the way down. You could see at this lower elevation here.
Like a driveway?
Yeah, because we had heavy equipment
going
through here, excavating this entire space out, which you'll see shortly, right?
Okay.
So it's creating the access, right? Then you just get to work, right? Demolition, excavation.
So what's the demolition here?
This used to have a foundation. You could even still see remnants of this brick foundation here.
Oh, okay.
So this is, everything's shored right now. This has no foundation currently. It's all on temporary shoring.
So where was grade level here?
Grade level is right
here. Right here, right?
Mm-hmm. Yep.
Okay.
Yeah, so
this
grade
was
level
where your
came.
house was.
Yeah, and then it just slowly started to kind of taper down.
So this was all dirt.
It was all dirt.
And you got to excavate this, get your workspace open first.
Mm-hmm.
And then what? You start going into the foundation?
Yeah. Then we start shoring.
How does the house not?
So we go into the crawl space first and we dig pits down to below what the future finished grade is going to be.
Oh,
so we have to dig all these holes underneath, and then we install our shoring. So now the house is supported temporarily.
So
right?
while the house is still standing, you go underneath the house.
Yep.
Dig down 20 feet or so.
This was about 10 or so,
feet?
yeah.
Okay, so you dig down 10 feet.
Because we had a couple feet in the crawl space.
Sure.
And then it tapered down to, I think, 4 in our best, area.
Okay.
And you create, a firm compacted pad that then you can build your shoring off of. And then we put huge beams in, and then you run these big columns and the shoring through these holes, and now you can start digging.
And what is the shoring, like what is the actual structural or mechanism of the shoring? Is it just
timber?
Timber.
Timber,
Just
just heavy wood, yeah.
Okay, and you're just building posts basically.
Yeah, big columns. We engineer, all of it's engineered to take all the loads of the building. It has gussets, like you can see these plywood gussets, so it doesn't move laterally.
Gusset is the triangle?
Yeah, that big triangle there.
Like a shear wall basically?
Yeah, because it's temporary. When we dig these out, we get these foundations in pretty fast.
And so the way you guys shore it up, I'm assuming this is like built to withstand like normal conditions, an earthquake or anything, right?
Mm-hmm.
Wow.
That's right.
Okay.
Yeah.
So you go in.
Demolition, you demolish everything, you excavate everything, you export everything, so you have just loads and loads of dirt coming out of here.
Yeah,
right?
Dirt, brick, rock.
And then you start
whatever
cutting
else you find in the foundation.
Junk,
you guys find anything
1920s.
crazy here?
I mean, we always find crazy stuff.
Yeah.
So, weird, weird creepy dolls. Yeah, weird creepy dolls. trash, a lot of metal, old license plates, parts of cars, rims, you know, from the 1920s, lots of bricks,
Yeah.
concrete road. I mean,
What year was this house built?
This was in the early 1900s.
Wow.
Like very early 1900s, you know.
Okay.
Yeah, this was a pretty big craftsman for this area. You know, if you look at and see how big the porch is, this was an older craftsman.
Okay, so then you demolish everything.
Yeah,
and
rip
you're
everything
basically
out,
left
shore
with
it.
Just your shoring.
Just our shoring in a big open space. Then you start to sculpt and excavate all of the foundations for the retaining walls and interior foundations,
Okay.
right? So this portion is sort of a final phase, but you'll see sort of how it works when we go underneath the basement right now.
Okay.
Once all the foundations are excavated, then
Well, if the foundations are next, should we go there and see what that's like?
Yeah, let's take a look.
Okay, let's do that.
Okay.
Hard hat time.
Gotta wear the hard hat.
Yeah.
All right, this is it. Fully excavated.
Okay.
1,300 square feet, something like that.
Wow.
You know?
So then this is before all this framing, and we got a lot going on, but the first thing you guys do once it's excavated is the footings.
Yep.
Okay, so you pour your footings, then what?
So footings are all poured, retaining wall footings are poured, retaining wall is shotcreted, right?
What does shotcreted mean?
Shotcrete is a pneumatically applied, sticky, high-strength concrete that is shot out of a nozzle.
Oh,
so for example, these
you spray
footings,
it basically.
Yeah, these footings were poured, right?
Yeah.
And then of course the walls were shotcreted. Those had a big nozzle, you know, nozzle applied concrete sprayed.
And why do you do that?
It's just the application that you use here where setting forms and tight access isn't the best way to go. So people use them for pools. If you're using like soil as a backing, we obviously didn't shoot this against soil. These were shot against forms, but.
Is it just a different, application method? It's not like the actual concrete itself has any different structural elements?
Yeah, it's both.
Oh.
Shotcrete is a higher strength concrete.
Oh,
too.
really?
Yeah.
Okay.
Yeah.
I would think pouring it in is stronger.
No. Shotcrete,
Interesting.
shotcrete is a very, very specific application and means and methods. It's you can do gunite, shotcrete. They both have different applications. One is shot dry, one is shot wet. So shotcrete is wet, and it sticks on. It cures fast. It's really good for tight access, right? Where you don't have a lot of room to vibrate the concrete. We use shotcrete all the time.
Okay.
Yeah.
Cool. So then you got your footings, you got your retaining walls, shotcrete,
Yep.
and it's still shored up.
Yeah.
So this
still shored
framing
up.
isn't here, right?
That's right. None of this framing is
None
here.
of this framing. What about the
Yep.
beams? Are the beams?
Beams. Some of the beams we strategically placed for shoring.
Okay.
But no, a lot of the beams weren't here. There was a massive steel beam all the way across here that obviously we took out. So this shoring is still temporary here. See this one?
Yeah.
So none of this framing is here. It's just wide open with a bunch of temporary beams and temporary shoring.
Okay.
Right?
So then next?
Then we get into, once all these foundations cure, right, and we can actually load the house onto them, you can't just pour foundations, let them cure for a day, and then start framing and let the house set onto them, right? So yeah, there's a curing period.
How long
right?
is that?
Generally 28 days.
Oh, wow.
Yeah, but depending on the engineering specifications, you can load earlier than that.
And what is that? Just to let it sink and sit in the soil?
Yeah, so there's curing. The concrete has to cure. It has to harden, which that's where it derives its strength, is when it's curing. And then of course, when you pour new foundations, when concrete cures, it shrinks a little bit. So you'll get a little bit of typical settlement where the foundations will slowly settle a little bit. So we want these to cure, before we load this existing house back onto this new foundation.
Okay.
Right?
So you let it cure.
We let it cure. We're doing a lot of cleanup, ancillary work, retaining walls. So there's a period of time where you can kind of stagger that portion with your retaining wall work on the exterior, right? Then you go right into structural framing, and that's what you see here. This is all the structural framing that's happening. It's not done yet, right?
So this is the phase you guys are in right now.
That's right.
Okay.
Yep. We're in structural framing and plumbing. So plumbing was just recently, completed, and structural framing is still underway. We still have another footing to do there. We actually changed the staircase here. The client wanted to change here. That's why those foundations aren't poured. So even in construction, things change.
Yeah. Okay, so then you guys are in framing right now.
Yep.
You got your beams in. What's left of this framing phase?
Just clean up on structural framing. We have a little bit of calibration to do on the floors. Obviously, lots of hardware to do, but most of the rough framing is complete. It's just the details that you pick up,
Sure.
punch list stuff.
Okay, then what's next?
Then after framing is done and plumbing's complete, then we pour this slab. We bring in base. We bring in heavy vapor barriers, right? Because obviously this is now living space.
What's a vapor barrier?
Vapor barrier is a heavy plastic sheeting that goes underneath the slab when you have a slab on grade foundation. So
on the
moisture
dirt.
doesn't, yeah.
Okay.
Well, it technically doesn't go directly over the dirt. It goes over the base or the sand, the sub base, what we call. And that prevents moisture from leaching through the slab because this is a finished space now, but it's subterranean on three sides. I mean, it's technically subterranean on all four sides, but we pushed out these walls outside of the building edge, right? So base, vapor barrier, then we'll finish up all the reinforcing steel, and then we place concrete for this slab pour.
Okay.
Yeah, then we'll be walking on, we'll be about 6 to 8 inches higher
Okay.
from here. You can kind of
Basically
see where that string line is there.
Yeah. Okay. So then you got the slab. What's
Yep.
next?
Now we're nearing completion. So now we place the slab, structural framing's done. Now we're going to wrap up the porch, all the foundations for the porch, all the seismic for the porch, and then we complete all of the little stuff, all the blocking, all the little hardware.
What's blocking?
Blocking fills all these joist bays right here, right? So you see these openings above the beam, right? That's part of structural framing, but plumbers, they need to do, plumbing runs and things like that. So, and you just wrap up the sort of the final details. We pour the outside exterior slabs, and we're out of here.
Nice. So then once you guys are done, then the contractor comes in and actually finishes it.
Yeah. We're still, the general contractor is working on this job. So there is trade overlap. We coordinate all that.
What are they doing while you guys are here?
They're doing, their plumbers are the ones that roughed in all the plumbing. We coordinate with them and say, hey, okay, where do you want your sleeves for your plumbing? Where do you want this? Where do you want that? We time pours with them to make it easy for them. And then once the rough is done, now they just get to go to town. Now that's their job to make everything pretty. So they start doing insulation, they start doing drywall, they start doing the exterior stucco, windows, start taking windows out, just everything that's involved in whatever that project is. In this case, everything.
Yeah.
That's what they do.
Nice.
Yeah.
Hell yeah. Okay.
And yeah, from the previous owner.
What do you do in that case?
That's this, This is what you do in that case.
This was all unpermitted?
Yeah, just so much leaking, water leaking, leaks all over the place.
Really?
And just a crooked, you've never seen such a nicely finished house that was so crooked. Like you walked in and the floors were like perfectly level, but the ceiling was so crooked.
Oh, the ceiling was crooked?
Yeah, because the whole house had settled.
Oh, interesting.
Right? But they didn't fix it.
But the floor wasn't?
The
You're floor good, Jewel? The floor was flat?
We want you in the shot. Where are you going?
So the floor was flat, but the ceiling was crooked?
Yeah, they floated the floors, but the ceiling was 6 inches out of level. Yeah, it's really.
So I always look at the floors to check for that, but I never think that they may have just
the sneaky
artificially.
The sneaky ones float the floors.
Interesting.
Yeah, the ceiling always gives it away.
Wow.
Yeah, I caught a house in Palisades, Malibu. It was a flip, really nice. Just absolutely gorgeous. It was like $10 million house. Had a landslide. The 5 neighbors put like millions of dollars into this one retaining wall landslide fix. It was a massive landslide repair. But the developer who bought the house poured like 3 trucks of concrete inside to level everything. He raised it 12 inches, but he foolishly didn't realize, or he did, that he's just adding like tens of thousands of pounds in weight to a building that already is sinking. So like 3 months after my client purchased it, it's just cracking all over the place.
Oh my God.
And that's when we discovered it was leveled. Yeah, that didn't go too well. You know.
So then do you go after that contractor? In
I
that
mean,
case?
we don't know.
Well, not
but
you, but the homeowner.
most of the time we see that. Yeah.
Wow.
Yeah, we see that. Yeah,
Okay.
it's pretty crazy.
So then we're here. Wow, this is a cool view.
Yeah.
So then this will be a deck.
Yep.
Okay, and then you got your pool.
Yep.
You got your nice hedge perimeter. What'll this be?
This is
oh,
going to
this will
get
be
built
deck.
out. Yeah. Ripped out, deck replaced. That's all the pool mechanical has to be replaced. Yeah.
Oh, is that a jacuzzi?
Yeah, that's a jacuzzi. He still wants it. I think it's teak.
Yeah. Nice. Okay.
Yeah. So outdoor is going to be beautiful, and then this is going to be obviously graded, leveled, right? This is a big, sort of roof deck, if you will,
Yeah.
but with living space underneath it. Right?
Okay.
Yeah.
Taylor, I don't know if it makes sense, but are you able to get us with this in the back?
If you guys
You want to stand up
this way,
there?
Then I'm up above.
Okay.
Yeah.
Is it?
Under here, I need to worry about standing up.
That's all. Yeah, that's all rebar. You don't want to step on that.
Just my own health.
Yeah.
Is it? Should we go back or is this good?
This looks good.
Okay, cool.
And on your time.
All right. Are we able to get a little more neutral angle?
I like Neil.
Okay, sick.
Maybe you want to come closer to me and turn a little bit more. Yeah, there we go.
Okay, cool.
Gotcha.
So,
With notes.
Yeah.
so the question we all want to know:
Mm-hmm.
what does this cost? The structural parts, your involvement.
It's a great question. So obviously every project is different. This one was a rather complicated one. It has, offset retaining walls. It has roof decks. It has obviously huge amounts of subterranean space. So this project just squeaked into 7 figures for this.
Okay, so just over $1 million, and that's the structural elements.
Yep.
So
Yeah.
that basically considers from breaking ground
Mm-hmm.
into getting to where you guys are going to finish and let the GC finish up.
That's right.
And do you have an idea what the GC's involvement is going to cost?
Yeah, I believe the GC is around because now all the infrastructure's in.
Right.
So
That's
there's
all
some,
the heavy lifting, basically.
yeah, there's some minor plumbing. The ejection pit is probably the most expensive plumbing component.
What's that?
That's that well right there.
Yeah.
That ejects all the gray water and sewage and it ejects it into the sewer line at the street.
Okay.
Right? So I believe it was around $500,000 for everything
Okay.
finished.
So the homeowner's looking at somewhere, and that doesn't include planning and permitting fees, right?
That's right.
So the homeowner's looking around somewhere around 1.7
Yeah.
for this whole build out.
Yeah.
And they're adding 1,300 square feet.
Yep.
And it's an ADU, so it's technically a second unit.
Yeah. That's right.
Okay, sweet.
Yeah. And it's sort of, but it's designed to complement their lifestyle. Like
Sure. Yeah.
I don't think they're going to be renting it.
Yeah,
you
yeah,
know.
yeah.
But
Yeah.
yeah, that's for this whole build out. Plus, obviously, we're regrading the entire yard, right?
And they were already looking at into 6 figures for just repairs.
Easily, just in repairs. Plus, probably 200 in cosmetic work because
Oh,
it
wow.
needed an 8-inch lift.
Oh,
so
wow.
all the windows were getting busted out.
Oh wow.
Yeah, there was major cosmetics.
So they were looking at 400,000 in repairs.
Yeah, they were probably looking at because this foundation needed to be replaced on a caisson supported foundation. So they were probably looking at between repairs and cosmetics, structural repair and cosmetic, at least $500,000.
Wow.
Yeah.
So they were like, all right, let's just do 1.7
Yeah.
and build it out.
Make it a perfect oasis.
Yeah.
Make it enormous. It's already a big house. Now it's
Yeah.
even bigger. And this area, it just made sense to do it with
Yeah.
how valuable the
So
house
this will
is
be
out
a
here.
3,600 square foot house. Wow.
Yep.
With a pool,
With a
great
pool,
location, in
deck,
Silver
roof
Lake,
deck, views.
craftsman home, and it's still. I mean, I saw the photos originally. It's beautiful in there.
It's a beautiful house.
Yeah.
Beautiful house. Just was really, really distressed.
Yeah.
Okay, guys, so let's get into the cost here. The homeowner bought this house back in 2020 for $1.8 million. And you heard it from Kyle. The total cost for this project is about $1.7 million, which means the homeowner is into this thing for about $3.5 million. Now, based on my calculations on what it'll be worth after the project is complete, I'm estimating about $3.8 million, but probably even more than that. But I don't want to overshoot it. So let's just take 3.8 million. Now that means the homeowner is building $300,000 of equity here. And you might be thinking that that's not amazing, but what you might be forgetting is that they were initially looking at $500,000 of repair costs just to fix what was wrong with the property and make it safe and livable. So rather than being down the hole $500,000, they're profiting $300,000. So overall, an amazing move on the homeowner's part and an overall job by the contractors and Alpha Structural.
Sweet.
Yeah.
Kyle, thank you so much. That was awesome.
Michael,
I
good
can't wait
seeing
to
you.
see when it's done. I have to come back out
It's
and
going to
see
be
it.
pretty cool. Yeah.
Yeah.
You have open access. Just call us and we'll
Hell
give you
yeah.
a tour.
So thanks for watching, guys. If you guys want to see more home renovations like this, then subscribe for more.